Welcome to our Tailgate Talk number 3. Appreciate you taking the opportunity to watch this. Today we are going to talk water and moving water from one place to another. Will Boyer. Will is our Northeast Kansas K-State Research and Extension Watershed Specialist, and he's going to share some tips and tricks about how to get water. If you've got a place that needs water, you've got a place that you need to get it from one point to another, he's going to share with us some information today to help us out with that. So, Will Boyer, thank you for coming to our Tailgate Talk 3.
Thanks, David. Appreciate the opportunity. So yeah, getting water out of a pond and into a tank is what I'll cover a little bit, and try to cover it in a fashion that's relatively inexpensive. We've had a lot of people asking us about, fencing out a pond and putting the water below the pond, and that works, but that runs into quite a little construction and expense. And also in the past we've used systems like this and a submersible pump that you can get on the market from a number of different suppliers. And those systems, what we were doing 10 years ago and up to the last couple years were pretty expensive. At least $2,500 to get all set up. The panels have come down some, but the cost of wire and cost of the pumps hasn't changed, or sometimes maybe even bumps up a little bit. But for just pumping out of a pond, you don't need to have a whole lot of lift to get it to a tank, and that type of pump that is designed for pumping out of deep wells is more expensive than what you need, and we're trying out some new things. Anyway, with this old system, it has to run on 24 volts, and these two panels here are 12 volts each, and you stack them on top and get the 24 volts. And I've actually continued to use the two together, but now I'm starting to use just 12 volt systems and bringing a battery in, so you got a little bit of backup storage. The battery is nice if you're wanting to do rotational grazing, or if you're in the wintertime you need to be able to keep that water moving at night, or actually I have these little heaters that I'll show you as well. But to get this 24 volt system switched into 12, just got to disconnect the stacked connection, and now I've got two separate 12 volt systems. And then these two boxes here, they both have the same thing in them. They're charge controllers, which manages the voltage and the amperage going in to your pump. Make sure that your battery doesn't get overcharged, and make sure that your pump gets the right amount of voltage to it. So it avoids damage to the battery in both ends, overcharging, and then when you withdraw, if you're going into a cloudy period and you're pumping a lot and your battery gets low, it'll cut it off that way too. And then not turn back on until the battery's been sufficiently charged. So this is the power coming from the panels to the charge controller. This goes to the battery, and then this goes to your pump. Use these two pin connectors a lot, similar to what you see on sprayer pumps. That's what we're using all the time. So we got some consistency there. So the first pump we're going to take a little closer look at is made by a company named Seaflow. And at first it didn't come with the accumulator tank, and it had a poorer pressure switch, and we worked with them a little bit, and eventually they started coming up with this system that's already stacked on the accumulator tank and put a better pressure switch, and it seems to be working pretty well. One negative of this one is it's a diaphragm pump, and as well as the deep well one is a diaphragm pump, and in either case they can't pump as dirty a water. Pond water's fine, but if you had a lot of water meal in the pond or some things like that, it would end up clogging them diaphragms up. The big advantage to this one, it comes all packaged nicely and ready to go. And this one will push water a long ways and push it pretty high lift. So what we're going to do, this is a foot valve which prevents it from backflowing. And it'll self-prime at this little low altitude elevation. But if you had it very high, you'd need to bring the pump down a little farther. I'm going to pass that to David. He's going to feed it through that pipe. And the pipe has a little bit, maybe you can tilt over this way, has an intake designed to get it so that we're only bringing water in off of that top pipe there. And that keeps it out of the mud and gives us relatively clean water to pump to the livestock. So we're going to start pushing it out there. Put it. And you can see it with the length of pipe we have here, it's just sitting right on the top. I'll bring it back just to show you a feature that it has since it's not glued together. We can tilt this a little bit down and then it'll be all the way under the water, and if the water level of the pond goes down over the summer, we'll still be getting water. So that's looking a little better. All right, so back on this sea flow diaphragm pump here, we're gonna plug it in and start showing how much flow you get. You get 5 gallons a minute out of this pretty easily. If you're pushing it at 50 or 100 foot of lift, it might go down a little bit, but we'll give it a little power here and give you an idea what it does. So I'm gonna have David put on the Hudson valve there, and I'll show you. It's got a pressure gauge, and here's the pressure switch. It also comes handy with a little strainer to make sure that if you do get a buildup of weeds or dirt or any kind of material, it'll strain it out. So that's something that you do have to check pretty regularly, especially if you're pumping out of a pond instead of a cleaner water system. And the Hudson valve, I don't know if you'll be able to see it or hear it. You probably can't hear the pump running. It's nice and quiet, but as your water level comes up, you can probably, it's still pumping, and pretty soon it'll reach the pressure that's going to shut off. And it shut off at about 65 pounds. So then when the animals come and drink, the float will release and start filling up again. So that pump there, with everything on it, just the pump and the pressure tank and the switches, and it doesn't come with a pressure valve, so that's maybe $10. But everything else sells at about $200. You'll notice the unusual looking blue hose. That's supposed to not kink or collapse, and that's important on the intake side. On the outflow side, it doesn't matter. You don't need that. But having that or like a poly pipe, the harder walled poly pipe, and it's something that won't suck down like a normal garden hose could. The next thing we want to show is a cute little orange pump that you can find on the internet for as low as $40. But with the wiring and some of the fittings and everything, you better figure on at least 50. I have one of these inside that bucket. You see my fancy little swimming noodle on the top of it. Isn't necessary, totally necessary depending on the situation, but we did need it. We had a pond that we were pumping out of. It was down in Osage County, and it was kind of stinky on the bottom. We used that other system first, and then we went to this one because that water was stinky on the bottom, but if you pump from more of the top of the pond, it was smelling a lot better and more desirable for the animals. Also, I use that in the winter time, and I'll get to that portion of it. You can not have that and just throw this bucket out, and you can see with the little weight in the bottom will sit on the bottom of the pond, and then the intake will be where these holes are at, a little bit up off the bottom. But in reality, this pump can handle a lot of sludge and dirt. It looks kind of like a sump pump, and pretty much is the same thing. It has what's called a centrifugal impeller in the bottom of it. It'll pump a large volume of water, like it'll probably do 20 gallons a minute, but it does not lift the water very high, 20 foot probably at the most, for this particular 12-volt one. One of the really nice things about that centrifugal impeller, though, which is different than the diaphragm, it'll allow the water, when the pump turns off, to float back out of the pipe downhill back into the pond or into a well, which can be important in the wintertime when you're dealing with freezing situations. So anyway, we got a pump like this in the bucket, and we also are going to need a mechanism to shut the water off when the tank gets full. Since it's got that impeller and it's high volume but low pressure, that pressure system isn't going to work the same, so we have a different system. This little float has a switch inside that'll turn the pump on and off. A negative to this is you lose a lot of the current through a long wire. This one's probably longer than it might need to be in some situations, or not long enough in others, but if you have to go any longer than this, you're going to have a current draw that is going to reduce the performance of the pump. So I'm going to just set this inside here, and so this cord's the power going to the pump, and we're going to put this little connection in here that goes to the tethered float, connected up here, and basically this float is going to be the circuit breaker that'll turn the pump on and off. So then this one will go to the charge controller. So we got the tethered float hooked up to the charge controller and to the pump, and the pump's inside here. I'm going to just give it a little toss and let the bucket fill up with water. Now, if you're worried about wind, being able to throw it out there and just let it sink to the bottom might be a better option. So you could take that off. In one pond, the one I mentioned a little bit ago, we actually had a rope tied to the bail of the bucket, tied it on one end to a tree on this side of the pond, and another side of the pond we tied it to another tree, and it's stable out there. So anyway, what we need to do now is be the cows come to get their drink, lower the water, and then turn the pump on. And we got water coming out. David, you want to show them what we got?
Oh.
Yeah, that little pump will provide that, from just this little amount of lift will provide that 20 gallons per minute pretty easily, so it'll fill that tank up pretty fast. And it's as simple as that to shut it off. So that pump is pretty inexpensive. It does require that you have a 12-volt battery for storage, but if you're moving your system around a lot, that's a good option. You could have a 24-volt pump system like that. This one here is 24. And be able to reduce the amps enough so you could probably run it just off of 2 panels and not have a battery system, and then store your water in a storage tank. In either case, you know, you want to have backup in these systems, because always can go wrong, and it could just be that the sun's not shining enough, or you could have a problem with the wiring or some of the mechanism, or a leak in the tank. So you need to be ready. And in this particular case, this is a 24-volt pump, and you can actually take this little step-up inverter and plug it onto your 12-volt battery in the vehicle and run the pump off of your 12-volt battery. And it's even easier with the 12-volt pumps. You just have to have a wire with alligator clips, and you can see we use the 2-pin connectors, so we can plug that right into the pump. And if we show up to the tank and it's empty, and maybe your battery's flat, you really don't want to bring a fresh battery there and use the juice in that battery to fill the tank, because by the time you do that, you're going to be right back where you were with the flat battery. So if you can fill the tank with the charge off of your running vehicle and have that tank full, and then bring your fresh battery in, then you're going to be in good shape to get going again, assuming you continue to get some sunshine, or you fix whatever problem, the leaky tank or the problem in the mechanism. So that's a really nice pump for pumping low elevations, perfect for pumping out of a pond to a tank adjacent to the pond. Really excited about that one, and looking forward to sharing that with more people. So I got one more style of pump to share with you today. It's called a helical pump. It has a different pumping mechanism. The first two that we looked at were diaphragm pumps, which just had these tiny little rubber or Teflon diaphragms, and they just go beep, 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 and pump the water, develop high pressure, and able to lift water really high. The second one was this style with that centrifugal impeller at the bottom. It's just a flat little thing with some fins on it, and it spins quite fast when you put power to it, and then when it turns off, it lets that water flow right back down to the pump. This one is a helical pump. It has a shaft. Some people will call it like a worm gear pump. It has a shaft on it that's kind of well, like a corkscrew or a bottle opener for a wine bottle, and then a little rubber thing on it, and it kind of wobbles and does whatever it does, and gets water flowing into your hose. It will lift water quite well. This is an inexpensive one, and it'll lift 75 feet or so. More expensive ones will lift 500 feet and give you the ability, also the more expensive ones give you the ability to hook it up to AC or DC. So if you're low on water, then you can, and you don't have sunshine, you can bring a generator out and hook it up to that one. But that one is way more expensive. This one was less than $100. So I'm going to give you a look at what it looks like, just kind of to show you the flow here. Pretty similar, but the gallons per minute is going to be quite a little less, but it will give you a lot more lift than that sump pump style orange one that we looked at. So we're going to plug that one in and see what it'll do. David, you got the hose? So like I said, that'll give you quite a little bit more lift. Another thing about this though is pumping pond water is maybe a little questionable for it. You should probably, if you're going to pump pond water with it, you probably should put some sort of a screening around the pump to make sure that you keep the junk out, because they, in the advertisements, mention that you need to have relatively clean water, or you're going to be replacing that little rubber piece that does the pumping action. So next we're going to move into some of the challenges of doing this. So far this has all been stuff that you can do pretty easily in the summertime, but we'll move into talking about some of the challenges of providing water in the wintertime with solar. So you saw how we were able to turn this 12-volt sump pump style pump on and off using the tethered float system. Just basically breaking the circuit with this on-off switch. When the water level goes up, turning the pump off, and when it goes down, turning it on. One of the negatives of that is that the tank, especially like if you got calves drinking, the tank has to get pretty low before the pump will turn on and refill again. So if you have a small tank and calves drinking, they're going to have to wait. The other negative that we mentioned is you're going to lose capacity of your pump if you have a long distance and a long wire because of the resistance of the wire. You could put a heavier gauge wire on there and help a little bit, but it is definitely a disadvantage. So one way to get around that is to use this system, and this is kind of one that we started with, this advanced power. So if your pump is drawing a low amperage, you can use this system for turning it on and off just directly. It has these two prongs that go in the water and senses the continuity of the circuit through the water. You got to watch out that over time they have a little buildup of calcium or some other substance on them that needs to be scratched off to make it work. But the 12-volt pumps that we were using were drawing a little bit too much amperage, so we ended up putting a relay on, not a relay, a solenoid onto the system, and that way we can turn the pump on and off with a smaller wire with less amperage. The solenoid was, it works all right, but there's a lot of wires that you have to attach to it, and the more wires you have, the more potential trouble you have. A little bit cleaner system that serves the same purpose is a relay, such as this one. This one's waterproof, and it's 40-30 amp relay. We also got some that are a little higher amperage, and this is a place we also have a fuse in the system that kind of helps protect things. So you can use this lightweight wire to turn the pump on and off. And this tiny little float just gives you a real small amount of change in the water level before it turns on. This is just like less than $10 for this little float. The relay is similar, and we can put these together fairly inexpensively. So I'll hook this up and show you how it works, and then get into a little bit more of the wintertime watering issues. So we have the relay system hooked up now. The relay is in that PVC pipe back at the panel, and you can run whatever gauge wire you want. It can be really small, as long as you don't have problems with the gophers and the mice and everything chewing on it. A long distance to wherever your tank is from the water source. And we have this simple little stainless steel float hooked up into this PVC pipe that we can hang over the edge of a tank. And when the water level goes down, the pump kicks on, and then the water level comes back up and it'll shut it off. So it's all being controlled by that little relay, just like the ones that are in a modern car today. So we're going to move right on into dealing with some of the challenges of providing water to livestock in the wintertime with solar power. And the one main challenge is that the days of sunlight are a lot less. So having maybe an extra panel, maybe an extra battery helps deal with that. As you notice, the angle of the solar panel is relatively flat, and that's kind of where you want it in the summertime. In the summertime, what you do is to find somewhere close to the optimal angle at any time of year, or I guess summer and winter is where I talk to people the most, is you take your latitude, which is, we'll just say it's 40 degrees latitude. In the summer you subtract 15 degrees from that and set that at the angle, and in the wintertime you add 15 degrees to it, so you'd be at 55 degrees. So 45-50 degree angle in the wintertime, as opposed to that angle there that's relatively flat. So that's one of the things you have to do. And obviously you got to worry about the water lines freezing up. That's one of the reasons that this centrifugal pump is really nice. I mentioned this before, the water can flow back into the source. If it's a well, the well is insulated itself. So if it flows back down into a well, you really don't have to worry about that water supply line to the tank freezing up at all. If it's a pond, it's a little different story, or a stream. So if it's pumping out of a pond or stream, you have to worry about the water flows away from the tank back to the water source, but at the water level in the pond or the stream, you're going to have a chance for that hose coming up out of there. When it reaches the elevation of the water, you'll have freezing in your hose at that elevation. One way to deal with that would be to just set it up so your pump is turning on and running a little bit all the time to keep that water moving. And you can do that with an overflow in your tank. Put a little drill a small hole in your overflow pipe, and then it will just constantly overflow. And then periodically, when the water level goes down enough, your pump will turn on. That would be one way to do it. You may need to really watch your batteries and maybe have an extra one if you're going to try to do that. Or find a pump that draws less amps but still provides the lift that you need. Another way that I've just started experimenting with last winter and will do more of this winter is using a self-regulating heat cable. And this is a 12-volt cable, which looks real similar to the kind of cable that you wire your house with. It's maybe a third of the size. It only has 2 wires in it. In between those 2 wires is some kind of carbon substance. And as the temperature drops, it allows more electric flow between those 2 wires. As it warms, then the amount of current that it uses is less. So when it gets cold down, close to freezing, that's when it starts applying heat. And what I did was, with this little noodle here, I kind of regulated the height of this little insulated heater that has a heating cable wrapped around it. So that's screwed into the pump, and this has a little heat cable around it. And then that creates a second wire that you have to take from your pump to the solar panels and battery systems, and that's why we had two separate solar panels. One is taking care of just turning the pump on and off, and then the other is helping out with that heating system, as well as it can be used in the tank for keeping ice off of the tank for drinking. We use these little air bubblers. This is a fish aquarium little air pump here, and a small little air stone that diffuses the bubbles and spreads them out a little bit, so there's a circulation of the water. It reduces the issue of having to chop ice in your tank. So hopefully these little air diffusers will be able to create enough water motion in the tank that you will not have to do much ice chopping. Just to summarize a few of these things and cover a little bit of the costs of some of the components of all this, I wanted to cover that a little. For $1 a watt or less, you can buy your solar panels. So these two are 80-watt panels. More so, we're probably using 100-watt panels, and we're getting them for as low as $80. The charge controller, you throw that in, and it might get it up to $100. So another $20 for the charge controller. One real important piece of all this is the battery. Everybody's got batteries sitting around. They may or may not be able to do the job, and more likely not if they're just sitting around. What you really should have is a deep cycle marine battery, and I encourage, when we're cost sharing on these systems, I encourage allowing like at least $150 in the budget for each battery, and if you need 2, then it's just an expensive part of the whole system, but it's real critical. So I really appreciate the opportunity to visit with you via video today. Um, my position with K-State is grant funded, and the funding comes from the state of Kansas, and then some of it also is funneled down through the state through EPA's 319 program, and we work with providing cost share on these systems to people. And right now, a lot of what we're doing is just demonstrations, and so the big thing that we're trying to do is reduce the amount of watering that the animals have to do out of streams, and that's why we were, and also providing water to grazing cover crop fields, and that's why trying to do some of this from a stream in the wintertime, we were kind of challenged by KDHE to come up with reasonable cost systems, and it's been a lot of fun this last winter, and this upcoming one, I look forward to working with more producers on those types of systems where maybe you're pumping from an old dug well, or you have a stream on a crop field that the animals have to drink out of, and maybe we can get together through your local extension agent and myself and you and try to set up a system for watering for your livestock. Thanks a lot.